just a reminder of what I is. I equals the square root of -1. So we've done a lot of imaginary numbers. We did a whole unit on it in Algebra 2. So -25. I just want to remind you of what it technically is. When we used to tell you you cannot take the square root of a negative number, and that's almost true. The only negative number that actually has a square root is -1. Every other number does not. But if they write a number like this, the square root of -25, it's the same thing as -1 times 25. So really you're just taking the square root of -1, which is I, square root 25, and square root 25 actually has a square root, so it's 5i and -5i. Don't forget, when you take a square root, there are always two answers, a positive answer and a negative answer. Okay, so all of that should just be a reminder to you. So let's do one that's not a perfect square. Let's simplify. Really, it's 19 humps on the end there. Simplifying imaginary numbers. If they're not perfect squares, the process is still the same. So for example, -108. 108 is not a perfect square. When I look at this, I look at it as if it were, I know you're going to take the shortcut and it's fine. I just want to make sure that I tell you the truth. You're going to look at it like this, square root of -1 times 108. Because you can take the square root of -1, it is I. And then I have to take the square root of 108. Well, 108 is not a perfect square. It does, however, break down. So I'm going to break it down. 2 and 54, 2 and 27, 3 and 9, 3 and 3. Grouping in groups of 2, because this is a square root. I have 2 3's right here together. I have 2 2's together. This guy is all by himself. You go out in groups, a 3 and a 2 go on the outside. You multiply them, so that's going to be 6. There is already an I out there, so it'll be 6i square root 3. Positive and negative 6i square root 3. Because there is always both a positive and a negative answer when you take a square root. Okay? So, these are called complex numbers because they have both a real part and an imaginary part. So complex numbers are written in the form A plus BI. They will have a real piece and an imaginary piece. This piece is real, and this piece is imaginary. And so far, all of this is reviewed. Now, this next thing we didn't really deal with, but it's easy, so no worries. Complex numbers are equal if the real pieces are equal and the imaginary pieces are equal. So that's important. They'll give you a problem to use that. Well, what numbers x and y is 3x plus 4i equal to 2y plus x xi? Okay, so we're going to have to use the information that they gave us in the top. These two pieces are equal if the real pieces are equal and the imaginary pieces are equal. So let's start with the imaginary pieces because those are the easiest to identify because they have that I with them. So here's the imaginary piece of the left side, and here is the imaginary piece on the right side. So according to this statement, those two things have to be equal. So 4i has to equal xi. Well, that makes this easy. X, in this case, would have to be 4. That's the only way those two things would be equal. Okay, all of what was left has to be the real stuff, because if those were the imaginary pieces, that means everything else has to be real. So I have 3x equals 2y plus x. Well, I already know what x is. I figured that out already. X is 4. So I can plug that in. So 3 times 4 equals 2y plus 4. And just solve it, and I'll figure out what y is. It's 4. So in this case, both x and y were 4. That's just coincidence. It won't work out that way every time.
I like that.
Okay, yes, pretty simple. Okay, this next step is also very simple and stuff that you're familiar with. We're going to add and subtract complex numbers. Simple enough, I'm sure you remember. You can only add real pieces to real pieces and imaginary pieces to imaginary pieces. So in this first one, because it's positive, I don't even have to mess with distributing or anything. I can just add and I get my real pieces, 3 and 2 is 5, and my imaginary pieces are 11 and 9. That is it. Now, on the second one, just be cautious about your negative, because we're subtracting. I think it's easier if you go ahead and distribute the negative. So I'm going to have negative 5 plus 8i minus 2 plus 12. That way I can keep all my signs straight. Real pieces with real pieces, imaginary pieces with imaginary pieces. So this comes out to be negative 7 plus 20i. Okay, that was easy enough. This next thing is also easy. And we've done plenty of this. One little thing you need to make note of, in case you have forgotten this, but I squared equals negative 1. That's going to come into handy here.
Don't you get down and then over I squared and negative 1?
Yep. Alright, so we just have to distribute, or what y'all probably learned is FOIL. then combine like terms. Remember, imaginary pieces go with imaginary pieces. So this becomes 6 plus 29i plus 28, and I squared is -1, so I'm going to replace it with -1. I'm probably doing more steps than you would ever do, but that's okay. Don't want to lose anybody. So that would make that -28, which means your final answer now. You do want to write it in A plus BI order, so you want your real value first. So it's going to be -22 plus 29i. Let's do another one. It's good practice. +26 plus 8i. Everybody okay? Any questions so far? All this stuff you remember. Okay, so this next one, it is just like this. It's just going to start out looking different. But if you'll just remember where these things came from, it's the exact same thing. So they might give you one that looks like this to start with. You have to put these in complex form first. So don't deal with the radicals because they're not the same anyway. I couldn't multiply this times this. Well, you could, but it's not going to work. So you're going to fix it first. So I'm going to make this -2. Now, when you take the square root of a number,
You have to answer.
there's two answers, but we assume this sign to indicate to us which answer they want us to use. So on this first binomial, they want us to use positive 4i. And on this one, they want us to use negative 3i. We're assuming the value in the middle to show you which one you're supposed to use. Once you've done that, it's just a regular multiplication problem, just like the ones we just did. So I ended up with 4 plus 22i.
Yeah,
Alright, next. We're now dividing by complex numbers. Alright, notice this example came directly out of the book, and the assignments that you guys do on the computer are directly from the book. They want your final answer in A plus BI form. Always put the real piece first, and the imaginary piece second. Okay, so they're gonna give you a problem, and it says I am supposed to divide and put this in a plus bi form. Well, first of all, I look at it and it looks like there's nothing I can divide. But you have to remember where an I comes from. An I comes from taking a square root. You cannot have a square root in a denominator. So you also cannot have an I in a denominator. So you have to fix that. And remember, we fix it by using the conjugate. So I'm going to write use the conjugate, and then I'll remind you what a conjugate is.
Isn't it times it by 2 plus?
You're going to get close. A conjugate you change the imaginary piece to its opposite. So in this case, I'm going to multiply both the top and the bottom by the conjugate. So I have 3 over 2 plus I. The conjugate of 2 plus I is 2 minus I. If you multiply the bottom, you also have to multiply the top. So now remember, when you multiply fractions, you multiply straight across. So I end up with this. On top, you'll just distribute. On bottom, you do have to FOIL, but they're conjugates.
So
And
you're gonna say first
anytime
and last.
you just F and L, just first and last. You don't have to do the two inside pieces. So I get 4 minus I squared,
Which is negative 1.
which is negative 1. So I've got 6 minus 3I over 4 plus 1, because I had minus 1. So I get 6 minus 3I over 5. Now, you can't leave it like that and it be counted correct, because they specifically told you you have to put it in A plus BI format. So you just split the denominator up. If it belongs to the whole thing, it belongs to each piece.
So it would be 6 over 5 minus 3 over 5i.
Yes. Just like that. Hold on. Hello? Hey.
I like this. I.
Good. Good. So when
This
he's
is like
wow. Good. Okay. How are you? Good.
his routine. So you're just like looking at it. Struggle. Got it. You get 9 over 10 plus 3 over 10. I.
Writing a little I keeps like messing me up. Like whenever I write like 3s and 2s.
Oh, 2s is like 2s. My 2s look like my eye.
Yeah, I'm like I gotta like slow down and be like 2. I.
Like,
Yeah.
looks like a 2 with a dot.
Same.
Because my 2s almost look like S's anyways.
Yeah.
So I'm not very defined in my points.
So I got 9 over 10 plus the test.
Why do you guys want to?
310I. The same thing. I don't know, like, if it matters when you're doing it. Oh, me and Michaela texted me.
Did you know the lady from Knowles today was like, as in his stepmom?
Yes. I figured that out
That's
whenever
why
she was like,
Ortega.
Ortega.
I wasn't listening.
And then she was like, hey Jonathan. Then I was like, oh, okay, this is my school as his mom.
She was so good.
But it's not his. Oh yeah, it is. That's his real mom. Or no. Stepmom, and then he has his real dad. Are you really into it? I think. Take it.
Yeah, I'm gonna do the old ones.
Go to general.
So should I try the general review or what?
I got 9 over 9 and you got 8 over 9.
9 over 10 plus 3 over 10.
Oh, you're good. Oh, I didn't know there was that. Never mind.
You get
I did good.
my mom.
What a
I can
cutie.
do like
She is
9
so
minus
cute.
negative 1 minus. I don't want to add it's like 2 plus. I can get it to the day.
Your mom is gorgeous.
She's so weird.
I miss her being at the office side.
Just too much sometimes. Every time I cook my phone. Yay.
Here.
Tear. No, really, because my eyes are watering. Mine is twitching.
Okay, I'm just gonna let you know we are not eating golden chicken today.
When I'm tired,
I
I
just
don't know why.
Where do you want to go?
And it's just like this one eye.
I don't know, $2. I wanna eat the cheese.
They need to come like clean out
How am I gonna
her lights because her lights are like the worst out of all classes I've been to. I can get like a
Can
little.
you imagine just opening it and
No, I don't want
then
to.
Let's see that.
I'll just get a few.
That's
If
disgusting.
we went to Sonic, what exactly is that mean?
Yeah, I was looking at it. I don't know.
Why is there so many?
Where's McDonald's at? Like, where'd they even all come from?
And like,
I just like, I don't know, my digestive system is almost done. No, like, I just like, I can't figure out like my eating schedule. Like, it's all like wonky. So my
I don't
body's
even have it.
I like how I do. I like usually like have like a snack like during this time, and then I eat lunch, and then I eat dinner.
Okay, did you get 9/10 plus 3/10?
Yes.
All right, then you're good. I have to, my mouth can say it.
Was that
Okay.
your husband?
So, yeah. Okay, next, same idea. They will give you one that looks like this. It's just the same as multiplication. You have to fix it first and put it into complex form before you can divide. So this one would be fixed as 2 minus 4i. The bottom would be 3 plus I. Then you can worry about the conjugate part. I'm going to go ahead and finish it because this one actually,
Do we have to do it twice?
I think, simplifies. No. This one actually, because you have to FOIL on top. Oh, so let me say, bless you, let me say that. It is only the denominator you're concerned about having an imaginary number. So you don't have to worry about the fact that there's an imaginary on top. It's just the bottom that you're worried about. So you FOIL. And combine like terms. Don't forget, you want your real pieces listed first.
simplify that?
Yes.
So it'd be 1 minus 14i equal. or
It's
over
gonna
5.
be 1/5 minus 7i over 5. Because it does simplify. Because everything's divisible by 2, so I went ahead and divided it when I broke it up. Alright. This next thing is new, but could potentially be the easiest thing in this section.
Good.
Yeah, it's good. It's cheap. Okay, so
Depends on how you take
I to the first would equal I. Duh. Anything to the first power equals itself. So that's easy. And we just talked about this one. I squared equals -1. I to the third would equal, now think about this for a minute. In order to get I to the third, you would have to multiply I to the first times I to the second. That would give you I to the third. So you would multiply the answers. I times -1 would be
Negative I.
-I.
Yeah, it's better.
And then I to the fourth
Is still -1.
is 1. For the same reason. Because you would have to multiply, well, let's say you'd multiply I squared times I squared to get out of the fourth. Well, that'd be -1 times -1,
Oh.
which is +1. Okay, so,
And
the pattern repeats. So, I to the fifth is I to the sixth is -1, I to the seventh would be -I, and I to the eighth is 1. So because of this, this repeated pattern, which we call a periodic pattern, we can simplify all degrees of I. And it is super, super easy to do. So they'll give you one like this. All right, now, our pattern repeats every 4 degrees.
so divide that by 4.
So you're going to divide 365 by 4. You need to do it by hand
No.
because all we are concerned about is the remainder. And if you do it in a calculator, you won't get a remainder, you'll get a decimal. We want the remainder. So I'm going to divide by hand.
Okay, I haven't done this in a long time.
By hand.
All I do is for these and these and these.
Okay, so 9, give me 36, bring down the
Remainder
5,
of
1.
91 the remainder of 1.
Remainder 1. All you care about is the remainder. This is all we need.
There's something about this.
And then you just go back up and you find your remainder in the degree.
So it equal I.
So it equals I.
So I have 365. So 365 just equals I.
Mm-hmm.
Wow.
Okay, it's easy. Let's do another one real quick. I to the 1,999. equals negative I, because it's a remainder of 3. Good? Alright, now if they give you one like this, and they say, okay, I to the 28th power. Well, when I go to divide that by 4,
It does divide.
it divides evenly with no remainder. Well, what is anything to the 0 power?
Oh wait,
One.
no, it's 1. Yeah.
Yes. Anything to the 0 power is 1.
I like that. So it's 1.
So this equals 1. Okay.
Is that it?
No. Alright.
One
Okay, now the next thing is also quite easy. We've done this before. Actually, no, not the next thing. The next thing after this we've done. Okay. This next thing is new. Also. It's easy though. But it's new.
Does your hand ever get tired of writing over and over?
Yes. I try to not have to give like notes in every class in a day because it's too much. I get tired of hearing my own voice too. Okay, absolute value of a complex number. We never did this before.
Oh wait,
But it's pretty easy.
so like, since I don't know, I'll just be quiet. Is it mean like the absolute like value signs?
Mhm.
So like if it were absolute value of I squared, it'd be 1. If it's -1.
That would be.
Yeah, but that's not gonna be.
That's too easy.
Yeah.
This is it really is actually very easy. I think it's very easy if you don't try to understand it. If you'll just go with it and don't even try to understand it, because if you try to understand that, I think imaginary numbers as a whole, just try to understand it, it'll just blow your mind.
Yeah.
Just whatever. But if you'll just follow the pattern, it really is very simple. So this is the pattern. If they give you absolute value signs and inside of it they put a complex number, then this is what you're going to do. You're going to change the absolute value to a radical, and you're going to square the a and the b. Notice there's no I inside of here. It's gone. Because we squared it anyway. Don't try to understand it. It's just gone. It's just gone. That's all you need to know. I could explain to you why, but it's just